everyone, welcome back to expert structure. Today we will show you how to design 2D truss frame span 34 meter compared with the previous tutorial about single portal frame by using hot rule section. Now let's start by create new model. Okay, I call it 2D frame truss span 34 meter length. Okay, and for design standard we use UK national language and language English language. You can select other language, and here you can use other national language. Now we have to continue. Click OK. Okay, you show here the grid. Okay, and now we have to view on the grid of X and Z axis. Okay, and control 2. Okay, now let's start by drawing one line element, or you can create by using beam element. Now I just to create from the line element, and we have to create column length 6 meter. Okay, select it and copy it, and we have to copy, click one to another one and press it, and input the value is 17,000. Okay, meter, and the location is minus 17,000. Okay, the unit is in millimeter. Now we have to delete this one, and we create other beam segment. Okay, now we want to create a truss member. We have to offset here our truss member. The length is I have to select this one, and I can copy it to the height. We put set is 3500. Okay, in the location, and for the span we input the length, set enter 1500. Okay, enter, and now we have to create truss element by clicking here to here and choosing copy. You send copy and click on copy one, click from here to here. Okay, now you got the truss element. Now I want to delete this line. Okay, and you can divide it by 10 segment. I have to divide by 10 segment. Okay, you see here 10 segment, and after that you can create another new element. After you create the element, you can assign it as a beam and a column element later. It's no matter, you just throw it a line, or you just throw it as a hot rule section or other section. You can assign it later. Okay, make sure you input 10. Now I click from here. Okay, again I put from here to here, and if you want to create one by one, is okay. Now I want to copy it again. Okay, and we can input it by 9, and you click one point to another point. Okay, now you have another segment, and you also create the diagonal. We call it diagonal from the location to the location. It is diagonal. Okay, select here to here, and this one is also. Okay, You can create it one by one, or you can copy it. Now just to show you how to draw it. Okay, you can copy it easily and the fast way to be there, and to save your time. Okay, now I have to draw it. Okay, before just finish it, now I have to mirror. Okay, click on the mirror, and you have to select on the copy. If you want to move, you can select on move. Now I select on the copy and click one point to other point. Now we have the truss element. Okay, the roster. Okay, you see here, this is our truss element. Now we have to create for the section. We have to create the section. Now let's try create the section. Select on the structural element and click on section administration, and select on from library European. You can select from the American Imperial, American SI unit, and other standard section Chinese. Okay, now I have to select from the European standard section, and we use for the hollow section hollow. Okay, select from the SS. Okay, you can select the SS, select folder. Okay, this section or this section is also available for the sub section. Now I want to select it trial section. Now let's try from the upper chart. We select 200 multiply with 200 multiply with 80 multiply with 6 millimeter. This one. Okay, click on load, and for the diagonal we select 60 multiply with 40. Okay, and multiply with 3 millimeter, and click load. And for the bottom chart, you can select other section if you want, or you can take the section with the same the upper chart. Now I select it for the column. Okay, we take from the IPE. Now let's start with IPE 200. Okay, load. Okay, now we select on this one. We want to create it the same. Okay, it's the same. Now I want to hide the grid. I set to click on here and hide the grid, and click on the beam element, and we have to select for the section the upper chart is here. Okay, this select in the icon, click here and click here, and for the lower chart you can create the different, but now I just to select on this one, and I will tell you what is different when you select the bottom chart and the top chart different. What is different for undersea design. Now we have to click on it. Okay, in the section. Okay, it's good. Now we have to assign for the column. Okay, that is for the column. Now we complete the modeling. You to make sure you have select the earn one. Okay, click it again, and I have to select it. Okay, and this one is the same. Okay, now we have to let's start from the trial design area trial, and we fit it. We have to optimize from this 2D frame and continue to design in the 3D frame, and we have to assign for the load for the restraint. Okay, we have to select it for the XYZ and prevent rotate in the Z direction. Okay, click on here. Okay, click on here. Okay, and after that we have to input for the retro bracing or our frame. Now I want to show it a wireframe. I have to input it from here. Okay, you can input it from here. Okay, now you have to input the top restraint. I can copy it. I can copy it to edge and click on copy and copy. Okay, you have edge, and I can copy it to this one. Escape, try again, and copy it to this one and this one. Okay, and this one. And now we have to control S2 and again I have to select it all. I want to mirror it. Okay, mirror. You have to copy, click one point, second point. Now you have upper restraint. It is for the raster, for the raster. Okay, for the upper raster or upper short of truss. Okay, you have the Z section, or you have other section to restrain at the top. And now we have to continue by using the load from the previous tutorial. Okay, the previous tutorial is, I just to open it. For our tutorial that we take from 40 meter span pay, it is the same. We have to open it and we input the same load from the previous 3D tutorial single portal frame by using hot tool section. And for this one we will try to design from the 2D to complete 3D and compare each other what different when you design it as single hot tool section and compare with the transition in the previous tutorial if for the whole section. And now we want to try the load is the same, is 1.8 kilonewton per meter length. Now I have to input it here by create load, and you create the load combination, and I take it the load and create new load group, call it variation, and I have to create new load case, call it LR, but in this load case we select for the rows category, we call light load on rows. Okay, not light load on floor. And we have to create other one for the wind load. Okay, for the wind load create, and we call it wind edge. Okay, wind edge, and apply. Okay, now we have to apply for the deload. Okay, deload here is deload is 1.8. okay, 1.8. we apply for the, here is the coil axis. The coil axis is minus 1.8. You can also define it as a global axis. Okay, the previous tutorial we apply it for the global axis, so you can apply it the same, and click on here and click on here. And for the light load we apply it the same, 2.4. okay, 2.4. okay, copy and paste, and now Control Z, click on it and click on it. And the last one is for the win it. With it we apply for the column and for the upper raster or upper charge or the truss. Now we have to click on here and apply for the win load. We try to apply the same with the previous tutorial. 3.37 3.37. Okay, please click on 0 3.37, and we use the global axis in each direction. Click on here, and for the one we apply it 1.44 1.44. Okay, 1.44. And for the upper chart in this side, we have to apply the 2.54. Okay, and this one 2.66. 2.54 2.54 and 0 click on the local axis. Okay, and for this one is 2.66. okay, 2.66, and we apply here. Okay, now we just to complete model for the two different column with the apply load line load on rows and bin load in each direction. Okay, we have to click on this load combination. We click on it and delete for the default, and we have to create the load combination based on the table, based on the expression 6.10. And for the other reduction, you can according to the expression 6.10 AB, but in the case I want to got the maximum value, I just click on expression to 6.10, and visibility we have to check all and apply. Okay, now we have complete the modeling, apply load and load combination. Now we have to try to analyze it, and after analysis we got the error. We had to fix the error. You had to optimize our structure by adding other restraint, by adding other restraint at the column or at the bottom chart. Okay, now let's start from the previous one. We have to start from the linear analysis for other linear analysis. Okay, let's start. And now you have to check here to make sure your model do not have another error by clicking diagonal. Okay, no error. Okay, it's still pretty good. Now we have to click on the first order analysis. Okay, you can complete it, and you can check for the ultimate load. Okay, you can check for the internal force. You can check here internal force for the column, and for the lower upper chart you can check. Okay, and you can check for the other moment. Okay, now in the case we difficult to fix our structure because you do not get analysis for the buckling, and if you design you can get the pass or to the fair result. Okay, now we have to try it by using the cross section check only, because you do not active the buckling check. So if you design it for the section only, you will see, okay, your section is over. Okay, cannot see. Can you check here? It's over. Okay, it's over, cannot resist. Now we have to try to fit this section. We have to try by come back to analysis, click on the elastic analysis or location, and we click on second order analysis, buckling. We have to check on this option to fit our model and run analysis again. You can check here. It means the second order analysis mode is stable. Okay, so you have to press your structure again. Okay, to press to add more restraint. Okay, you can check for the buckling. The value of the buckling load is very low. It cannot acceptable. You see here is 0.44 for a chain value. For the whole structure, you have to measure at least 2, okay, 2, not below than 2. For the global stability, okay, in one is also not pass for our criteria, and this one is very low, okay, not pass for all low condition and not pass for all engine value. So the whole structure is not stable. You have to increase, you have to add more support, okay. You can add more support at the middle, and you can add more strain at the bottom, and you can add more section to increase your capacity of the frame. Now we have to check from here by clicking the low combination 1 and from the agent value 1. Now we have to start to check, okay. You see here in this section, it's called the global effect, okay. Our frame is way in its direction, in wind direction, okay. So you have to fit one case by one case, and you click and scroll, okay. You see here your bottom shot is deformed in another direction, okay. You see here in another direction, so you have to add the restraint at the bottom shot, okay. You have to add in the bottom shot, okay, to make sure your structure is not move away from the top and bottom, okay. So you can check other mode to know about your structure, okay. Okay, it's column. It affects too much on your column, okay. Let's try other up, okay, below. This one is the local buckling up here at the diagonal, and we have to try for other, okay, local, and also on the column in this one, okay, local buckling. This one is local buckling, okay. Now we let to try and to fit it again by adding more restraint, okay. I have to copy it and click on the copy, click on this one to this one, and we have to add the middle, and we have to add at the bottom, and we click on 4. We have to add 1 2 3, and this one is 1 2 3, okay. Now we have to test it again about the buckling mode, our structure, and about the agent value, it increase or not, okay. So we have to run this again. You see here the second order analysis in unstable, okay, unstable, but you can check about the buckling again. The value is very low, it's still low. You can check here, and we have to fit it again, okay. Fit it again. It is because your structure, okay, has the buckling, okay. Now we want to fit it again. Fit it again. You can check here. What is the solution right now, okay. What is the solution right now? Because your frame is not stable, you have to increase the depth of your frame, okay. In this one I can create this one to this one, and you can move it, okay. You can move it extract it. Okay, I had to delete this bottom shot. Delete. Okay, and you can extend it by using the command. Before you extend, you have to assign it a frame section. Okay, in this one, click here. Okay, you have to make sure, okay, you have a section. Now you want to extend it by clicking on the tool and click on extend. We want to extend this all, and we have to remodel our structure. Okay, because we take this one is not the right concept, so our structure is not stable. You can see the value of each value is very low, so you have to remodel your structure. When you assign the restraint for the column and for the frame but not stable, you have to correct it. Now I have to move it from here. Click on this location to this one. I can click on one. Okay, this one. As told you, we have to try together about design interior. Actually, I can complete the design by using the correct shape, but I had to explain you why sometimes we have to increase the middle section for the frame, because you see here when you check the each value is very low, you have to remodel your structure or your shape. It is a very important part of our tutorial. In this part we want to focus about it and how to correct about the problem that occur in our model. Okay, you see here. Now you have to check and to make sure your model is correct with your concept. Okay, now we have to add other restraint here by clicking copy and copy to this one and to this one, and this one we have already. And now you have to check about the load again. Okay, it's correct, and this one is correct, and for the reload correct. Okay, correct with our concept. Reload is correct. We have to save it again and click on the analysis. Okay, for analysis we include folder and buckling sensitivity and have to calculate. Now we have to compare it and remodel it one by one. Explain you why we modelize this and how to improve our frame structure and how to increase our exchange value. You can check here. Exchange value is increased more. Okay, exchange value is increased more, and you can check for the buckling shape. Okay, buckling shape here. For the location, you can see here. For the location, the buckling shape is in this part. It is very important to fit for the first mode. Okay, the second mode or third or 10th mode is really a pain. Really happen at the 10 mode. Okay, you can fit for the 1, 2, 3 or 4 mode. Okay, it is very good concept. Okay, now we have to try to add another restraint and the location, and we have to fit it again by copy, and we have to try. Now we have to check it again about the section. Okay, section is correct. Okay, now we have to create other restraint, and we have to check about when you create other restraint, the value of exchange value is increased or not. Okay, Now I had to add to the location 1, and okay, the location is really important, and we have to add in the location also, in the location and in the location. Okay, now let's start again by clicking analysis. Now we have to try to tell again and again. Okay, you see here the agent value is increased more or it's not increased more. We have the same. Okay, have the same. Now you have to create other diagonal. Okay, click on the member and I click on the correct location, correct section is here by clicking here, by clicking here to here, clicking here to here, and this one is the same, clicking here to here and clicking here to here, and you have to check the agent value again. Okay, you have to check. Okay, let's create a little bit, and you can check your model. Okay, it is for the deflection. We have to check for the serviceability deflection. Okay, and this one, our deflection is too much. Okay, you have to increase our section or column to reduce the deflection. Okay, you can design as a trial version by clicking on here and clicking on design of buckling and automatic for the sensitivity analysis or structure to take the value for the design of steel and design. You can check here our section is over. Okay, it's over. Okay, it's over in the location. In the location is not over. In the location. Okay, so you have to add more, add one more, and add one more section, and after that you have to increase for the section from IPA 250 to IPA 360. Okay, as a trial version. Okay, because we had to test it. Okay, now you have to make sure your section is correct with your design purpose. Click here. Okay, IPA is correct now. We have to analyze it again by clicking Save and click on Analysis and run it again. You can check it's about the agent value buckling. Okay, it increase more larger about the previous one. Is 5.15. This is very good now. When you increase the thickness of the column, and your frame also has more thickness by adding this diagonal, and you can check again about the buckling shape. You can see here no other effect of the overall buckling occur. This occur for the local member. Okay, it is very good. In here you can check. Okay, it is very good. Now the global buckling not occur. It occur for the local buckling only. It is very good. We want the shape. Okay, we want the concept, and you can click on global check, click on this location and include the buckling check. You can check for the cross section only without the buckling, and you will see the result. Okay, you have to check here. The result is 196.9. okay, you have to check here why this value is too high. Oh, you can check here because your model is not correct. Okay, it's not correct. Now after you fix this problem, your structure will be working fine. Okay, but you can check here. This one is not correct because you not connect each other in the joint. Now you have to check it, and I have to check it again. Okay, by clicking geometry and by strike tool, I have to strike this to the location, and it is the same because our HTML value is high enough, so we have to make sure our structure is safe. Okay, but because we have another shooting modeling, so we have to fix it before you continue to other part. Okay, you can save it and click on analysis again. Okay, you see the HTML view. Okay, not change too much. Okay, you can check here, and we have to start and design again for the cross section check only by clicking calculation, and you can check here what's wrong with here. Okay, what's wrong? This section is not passed. Okay, it's not passed. This section is not passed. This pass. Okay, you can check it. Pass. So in the case you can create more. Okay, more support at the lower truss structure here by create more. Okay, to reduce this value. Okay, now you have to create the geometry again and click on S2. Indicate you can add increase your section. You have another way to increase your section, or other way is to add more frame in this location. Okay, more frame in the location. You can select which one you want to shoot the value or the design value. You can check. It is correct. So we have to add one more segment in here. Okay, by clicking one, and we divide it by edge. Okay, I have to create in the location. Okay, and we have to and we assign the section again by using this section, and you have to check. Okay, this section. Okay, and we have to mirror it. Okay, you have to mirror it, and you can check it again. It passed or not, you can check it again. Okay, you see the buckling for the low combination. Okay, and we have to global check and design it again. In this case, we design for the. Okay, you see the value is dropped rapidly from the over 100% to only 54%. You can check here when you add this knee from the column to the frame. Okay, you can optimize this section again if you want. Okay, now our structure it says, you can check here, dirty ratio, and after that you can optimize the value of the diagonal again. But for 2D frame, you have to make sure you can pass the value is lower than 80%, and for the 3D model, the value will be affected by global effect, so you have to control by other effect. So in this for the 2D frame, you can optimize it up to 80%. Okay, in this case you can optimize it again if you want. In the count still, I do not know about the automatic optimization, but you can optimize by reselect the section and analyze it and check it again and again. I don't know where to optimize automatically in the design phase. Okay, now you know about how to design here. Okay, it is the value. You can check for the deflection again. Okay, this deflection is low, only 3 centimeter, 10 centimeter, and 2 centimeter, 2 centimeter, 1 centimeter. Okay, if you take the overall span is 34 centimeter and divide by permissible for the permissible deflection, I can take it 300. You can check here, is over divide by 300 is 113 millimeter for the vertical. Okay, in this one, and for the horizontal, the top of column is 10.8 millimeter. The permissible is hash. Okay, h, the value from here to here, it is 6 meter, and this one is 1.5 meter. And for this one, you can see it about the actual value. Okay, you can see it by clicking here and here. Okay, by clicking here to here. Okay, clicking here to here, and this one is the same. For the span is 34 meter length. Okay, so I take the value is 7.5. I can divide it by 7.5 divided by 150. Okay, 50 millimeter in our structure is only 10 millimeter is acceptable. Okay, it is for linear analysis, it is acceptable. Okay, you can check here about the design ratio, and you can check the view of design by clicking on check on the conservative interaction design ratio. Okay, for the apply load, for the resistance of the section, for the moment, and for the actual load, okay, so here, and you can check for other general elastic design, pure resistance for the compression bending and plastic design. You can check here. Everything is detailed in this table. Okay, you have to close it, and you can to optimize your section if you want. Okay, you can click it on, select on the frame section here if you want. Okay, if you want, but in this one I want to keep it the same with the bottom shot. Okay, with the bottom shot to make sure our structure is strong enough. Okay, and for the column you can issue from IPE 360 to other section by clicking here, and I clicking on the icon and loads again about IPE. I think it this one is enough. Okay, load, and we have to change it to 270, and you can run and let's see again. Okay, you have to check about the buckling. It is very important now. Okay, it is still good enough to keep our structure safe, and you can check again. And this one for the cross section design only, you do not yet apply for the buckling. Okay, you see here for the cross section is around 70%. Now you have to perform for the buckling check again, and you will see the ratio will be increased from here to upper value. Okay, now you got the value is around 85%. You can select for the higher value. Okay, in the location you can see here in the location, okay, you can see here, you can check, and our column now is working around 60%. Okay, around 60%. Okay, this one around 80%. Okay, this one is around 50%. Okay, now now you can mark up the result by clicking and mark. This one is also the same mark, okay, you see here about the value for the diagonal, value for the upper charge, and value for the vertical, and the value for the column, and you can optimize as you want. But it is for the 2D model. Now we have to convert it from 2D and analyze it and design for the 3D model. We have to compare about the value from the 2D and 3D. What is different when you apply for the 3D? I had to show it at the 3D. Okay, I call it 3D. Span 34 meter length. Okay.